Hello, pre-cal kids. I want to pick up in our lesson 4.3.1 notes where we left off, and I want to pick up exactly where we left off with this last example on the front page. We are working on finding reference angles, so I want to take a moment before we move to the back to remind you what a reference angle is. So if you look back at your definitions, a reference angle is the angle that tells us how far an angle is from the x-axis. It's always positive, and it's always between 0 and 90. So here, if we start thinking about 580 degrees, if you think about the angle 580 degrees and what it's going to do when we go around the circle, one key thing to notice is that 580 degrees is going to go around the circle more than once. And so when you have an angle bigger than 360, remember there would be a coterminal angle that would get it in just going around one time. So my recommendation here is we take the 580 degrees and we find a coterminal angle that is between 0 and 360. So I'm going to take 580 and I'm going to subtract 360 degrees. Do the math. 580 minus 360 is 220 degrees. And that is the angle we're going to use as we try and process a reference angle here. So, okay, if I get you guys thinking about 0 right there, there's my angle. And then 220. So remember, we start here. We're going to go counterclockwise. Remember, when we get to straight up, we are at 90 degrees. When we get to halfway around, like there, we are at 180 degrees. And we're trying to go to 220. So if you notice trying to go to 220, we want to go a little bit farther, but we want to stay in that third quadrant, because if we go to where it's straight down, we're at 270. So 220 degrees is going to be approximately here. Now, as we try and find the reference angle, how far is this angle right here, this 220, from the x-axis? And so if you consider the x-axis and you extend the x-axis, you'll notice, again, we are trying to find how far is 220 degrees from the left side of the x-axis. So we want to know that amount there. Keep in mind, the left side of the x-axis is 180 degrees. And so in order to find this, we're going to do 220 degrees minus 180 degrees, which is 40 degrees. So this angle of 580 degrees has a reference angle of 40 degrees. It is 40 degrees from the x-axis. Okay, get what you need from that one, and then let's proceed to the back side and work a little bit on this. On the back side, we are going to practice evaluating trig functions determined by ordered pairs. As you look at example A, first of all, realize it says find the 6 trigonometric functions of theta given the following ordered pairs. And the ordered pair we're given is 5, 3. Now, one thing to consider, let me point out, in an ordered pair, the order in an ordered pair is always x, y. Thus, 5 is my x value and 3 is my y value. The idea here is if we have this ordered pair, this point right there, it is represented by the ordered pair 5, 3. And this is where we can create a triangle. You see the triangle already drawn. By going over x units and up y units, we are creating a right triangle. In this case, when we go over x units, we are going over 5 units. When we go up y units, we're going to go up 3 units. And then your angle of reference that you're going to use, your theta, is always, whoops, that was kind of rough, is always the angle at the origin on the x-axis. So that's always our angle we're going to talk about. To proceed with this problem, we do need to talk about how to find the hypotenuse of our right triangle. Keep in mind, as we talk about the unit circle, another way to think about the hypotenuse is to refer to it as the radius. So this is also the radius of the circle. And realize in order to do this, we can talk Pythagorean theorem. I'm going to come over here to the left. And Pythagorean theorem, x squared plus y squared, and I'm going to say equals r squared, because my two legs are x and y, and my hypotenuse is the radius. So fill in the values. 5 squared plus 3 squared equals r squared. 25 plus 9 equals r squared. 25 plus 9 is 34. So r squared equals 34, or one more step, and r is the square root of 34. So this third side right here is the square root of 34. So there you have it. We have our three sides of the triangle. We're ready to find our 6 trigonometric functions. Oh, and before I proceed too far, let me point out, in order to find this radius here, we basically did Pythagorean theorem. If you prefer, when finding the radius, you could use this type of, say, formula, that it's the square root of x squared plus y squared. So that is an option in order to find the radius. If you want a formula that always works, that would work right there. And if you think about what we did, that's essentially what we did, because we had our 25 plus 9, and then we took the square root of it. Okay, 6 trig functions, which means I'm going to go ahead and write them out. We're going to have to find sine of theta. We're going to find cosine of theta. And we're going to find tangent of theta. And then, remember, we also have to find their reciprocals. The reciprocal of sine of theta is cosecant of theta. The reciprocal of cosine of theta is secant of theta. And the reciprocal of tangent of theta is cotangent of theta. And what's our saying to help us find our 6 trig functions? And that, of course, is SOHCAHTOA. So remember, sine is opposite over hypotenuse. As I mentioned earlier, our theta, our angle of reference, is right here at the origin. So opposite over hypotenuse is our y value over our radius, or in other words, 3 over square root of 34. And that's a good thing to know about the y value, or the sine, is it's always going to be the y over the radius. Cosine is going to be adjacent over hypotenuse. And we look at adjacent over hypotenuse, we're looking at the x over the radius. So 5 over square root of 34. And tangent, TOA, opposite over adjacent, or it's always going to be the y over the x, which in this case is 3 over 5. Now I have my reciprocal set up in the next column. As you recall, the reciprocal of sine is cosecant, and so that's going to be square root of 34 over 3. The reciprocal of cosine is secant, which is going to be square root of 34 over 5. And the reciprocal of tangent is cotangent, which is 5 over 3. And right there you have your 6 trig functions. Hopefully what we did there kind of made sense a little bit. I'm going to scooch that up just a teeny bit. Guess I don't really have much room there, do I? And now we're going to look at example B. If you notice, the only difference with example B is a negative sign. Now, again, remember that in an ordered pair, it is x comma y. Basically, all it's going to change is the sign on some of our answers is going to change. But I would like to encourage you to help visualize the triangle. In the first example, 5, 3 was in the first quadrant, so we had a first quadrant triangle drawn. In the second part of the problem, the ordered pair negative 5, 3. If you think through that, the ordered pair negative 5, 3 is in quadrant 2. Setting up a drawing over here for it. So the idea would be that if we go left 5, up 3, and it's not precise here, I'm just, we would have that point right there of negative 5, 3. And the idea that this would be an angle going through the point. You can form your right triangle, okay? So we form a right triangle there on the x-axis. We're going to drop a line straight from our point. The right angle is there on the x-axis. And again, the angle we're going to talk about, theta, is there at the origin. Now, as you try and label sides, think about the ordered pair negative 5, 3. We started here at the origin, and we went left 5, up 3. So we have an x value of negative 5, which is the bottom of the triangle, and then we went up 3, so the y value of 3 is the left side of the triangle. What about the radius here? If we do our Pythagorean theorem, or r equals the square root of x squared plus y squared, does that negative on the 5 change anything? And the answer would be no there because it squares it. So our radius is the same length of square root of 34. I'm going to go ahead and write out my trig functions. We're going to find sine of theta, cosine of theta, and tangent of theta. And then I'm going to find cosecant of theta, secant of theta, and cotangent of theta. So if you notice, again, theta is right here, right there in the center. That's our angle that we're basing everything off of. Sine, opposite over hypotenuse. So opposite being the 3, hypotenuse being square root of 34. 3 over square root of 34. Notice it's the same as the previous sign. Okay, cosine of theta. It's going to be adjacent over hypotenuse. Instead of 5 over square root of 34, though, just notice the differences. To have a positive 5, it is a negative 5. So negative 5 over square root of 34. If you're catching on, basically the only thing changes, anything with a 5 becomes negative. Everything else stays the same. Tangent, opposite over adjacent. So that's 3 over negative 5, or in other words, negative 3/5. Cosecant is reciprocal of sine. So square root of 34 over 3. Secant is the reciprocal of cosine, so this is going to be the negative of square root of 34 over 5. And cotangent, of course, is a reciprocal of tangent, so that's going to be negative 5 over 3. Hopefully this gives you a little insight of how to deal with the basic ordered pairs that you will see in homework. Now, notice the difference between A and B there. Sine and cosecant kept the positive signs. Everybody else changed to negative. And that leads me into the next part. So let me scoot my screen a little bit. And, okay, a note here. Angles with the same reference angle will have the same numerical values for the 6 trig functions. They will simply have different signs based on the quadrant. So, same numerical values, different signs. So, notice that had the same reference angle, guys. It had that ratio of x of 5 and y of 3. So they'll same numbers, different signs. Now, let me start, based on what I recall from past years, I've been referring to quadrant numbers. Are we all content with which quadrant is which? Because really, in order to proceed, you have to be comfortable with your quadrants. So remember, this is quadrant 1, our top right quadrant, and then we go counterclockwise. So here's quadrant 2, quadrant 3, and quadrant 4. And I have a saying we're going to use. I can't say that I created this saying. I will say some of your students come up with different ones. But our saying we're going to use is all students take calculus. Okay, that is our saying. All students take calculus. And what's important is the first letter in each of those words. A, S, T, and C. Okay, well, all is all, but the others, it's the first letter that means something. And so, all, quadrant 1. What that means is that all trig functions in quadrant 1 are positive. So if you look up at example A, the 0.53 was in quadrant 1. All the trig functions were positive. Okay, in quadrant 2, students starts with S. So what this quadrant is this quadrant is sign is positive. And what that means is sign is positive. Now, when I say sign is positive, please assume that its reciprocal is positive. So sine and cosecant are positive. Everybody else is negative. And that's what just happened in part B up above. We were in quadrant 2 by going left 5, up 3. Sine and cosecant were positive. Everybody else was negative. You might be able to guess where we're going from here. Take starts with T. And what we're going to say there is that tangent is positive in quadrant 3. Everybody else is negative. Now again, tangent is positive. That also means cotangent is positive. The other 4 trig functions would be negative. And last, calculus begins with C, and this of course refers to cosine. So in your final quadrant, quadrant 4, cosine is positive along with its reciprocal of secant. Everybody else is negative. So of course this is based on the 3 main trig functions. So know that phrase. I'll refer to that phrase a lot. All students take calculus. And that just tells you what trig functions are positive in what quadrants. And that leads us to example 4. Determine the sign of the following without using a calculator. Notice when we talk sign, S-I-G-N, so we are talking positive versus negative without using a calculator. In other words, no, I don't want you to take sine of 147 degrees, punch into your calculator, and see what you get. Couple of different ways we can think of this. Sine of 147 degrees. Easiest thing to do is to think, what quadrant is 147 degrees in? So 147 degrees is one you should be able to process relatively easily. So 147 degrees is over here in quadrant 2, correct? Q2 as I just put. Now, what do we know? If I use my saying, all students take calculus. What do we know about the sine of 147 degrees in quadrant 2? Well, in quadrant 2, it's S. That means sine is positive along with cosecant. Everybody else is negative. So the sine of 147 degrees is positive. That's probably your quickest and easiest way to think that through. If you want a little more processing and connecting, you can always draw yourself a little triangle and think that way. And if you think that way, keep in mind that as we were to go to a point, from the origin you would go left. And when you go left, that is a negative value. From there, you would go up. Up is a positive value. And the radius is always positive. And so if we think about our basic SOHCAHTOA, sine is opposite over hypotenuse. And if you look based on the origin, based on that angle there at the origin, opposite would be positive, hypotenuse would be positive. And a positive divided by a positive is a positive. Now that's the behind the scenes of how it all works, but All Students Take Calculus will help you pretty quickly. Okay, B, the secant of 5 pi over 3. Again, I encourage you to try and process it in radians. Now, first of all, secant. What do you know about the secant function? It is the reciprocal of cosine. So as I think this through, I'm going to remind myself that, okay, what I really need to think about is this is the cosine of 5 pi over 3. It is the reciprocal. Now, here's the tricky part. Where is 5 pi over 3? So think in thirds here. This, of course, is 0. Over at the left is 1 pi. What is 1 pi in terms of thirds? And realize that is 3 pi over 3. So as we were to go around, realize we would go past 3 pi over 3. Over here, 0 is also the same as 2 pi. And if you think about 2 pi, what is 2 pi in terms of thirds? And that is 6 pi over 3. So based on that information, where would 5 pi over 3 be? And you can assume rightly that 5 pi over 3 is going to be over there in quadrant 4. Okay, what do we know about quadrant 4? All students take calculus. Begins with C. And so cosine is positive and its reciprocal of secant are positive. So what does that say about 5 pi over 3, the secant of it? And that says it is going to be positive because of quadrant 4. Okay, one more. Tangent of 620. So what do you know about 620 degrees? You want to know what I know? It's big. So how do I deal with a big angle that I can't visualize where it is? I'm going to take 620 degrees and I'm going to subtract 360 degrees. 620 minus 360 is 260 degrees. Is tangent of 260 degrees a little bit easier to think about, I hope? Can you visualize where 260 ends up? I draw my x and y axis, 0 to 90, 90 to 180, 180 to 270. Realize that 260 would be right before that. So 260 is going to land in quadrant 3. And what's my phrase? All students take. So in quadrant 3, who's positive? Tangent and his reciprocal cotangent. So what's that say about the tangent of 260 degrees? It is positive. Okay, we're going to stop there, obviously. Hopefully that gives you a little bit of an idea of what you are looking at. Your homework to work on and see what you can do with. I'm going to put it up here because this is where I have room. Is on page 347. And it is numbers 1 through 7, 9 through 11, and 17 through 20. Okay, you've got your notes. See what you can do with the homework, and then when we go over it in class, we will definitely talk questions as we need to. Have a good day.